Hello everyone. Now I'm gonna introduce my project, which is Sentence Semantic Parser using OntoNodes dataset. So the problem in this project is that we want to design a semantic parser. So what can this semantic parser do? So we wanted to extract the 6 elements, which are very important key elements in the sentence. So these elements are subject, a predicate and object, and time information, location information, and the motivation of an action in this sentence, and the methods of an action in this sentence. So these elements can be described by using these words like who, what, when, where, why, and how. So the problem is that we want to extract these elements in the sentence that we have. So there are some existing approach that can do this kind of semantic parsing. So they can extract certain elements from the sentences. So for example, we have Stanford SEM3. So it is a semantic parser that can get some useful information in the sentences and do some question answering tasks. And we also have a parser that is designed by UT Austin. So for this parser, it can get some information from the sentence and also do some question answering problems. And then we have Google Slim. So it is a semantic parser that can get some semantic frames from the sentence we have and add these frames into our knowledge base to enrich the knowledge base. And we also have PredPad. So it is a specific semantic parser that can extract the subjects and the objects from a sentence. So our approach in this project uses this OntoNodes 5.0 dataset. So it is a large corpus of annotated sentences, and it has 3 languages: Chinese, English, Arabic, but here we only use English. And there are many useful views in this dataset. For example, we have tree bank view and prop bank view, and for each sentence it has different views, and among them we can use the tree bank view and the prop bank view to do the extraction. So now I will introduce a little about the tree bank view. So the tree bank view reviews the grammar structure of a sentence, and it has many levels. So it's like a tree. It has some shallow levels and some deeper levels. So for example, on top of the whole sentence, it is a level. And when it goes deeper, like for each word in the sentence, it is a level. And this level, this word level are usually very deep. So, and sometimes we can regard several words in the sentence as a chunk. And there are some levels in the middle for the chunk. And in this tree bank view, we have different kinds of tags. So these tags can indicate the grammar structures of part of the sentence. So this part can be a single word, and it also can be a chunk containing several words. So if we have a tag for a single word, it's called part of speech tag, and we also have a chunk tag, and we also have a relational tag. So the relational tag is a supplementary tag to the chunk tag, which can describe the relations between different chunks. So this is a sample tree bank view, and we can see that it has many levels, and they use these brackets to indicate the levels. And there are different tags, And sometimes for each word, it have several tags, and you can see that we put each word in the sentence in an individual line, and these lines are arranged in the order of these words in the sentence. Now I will introduce the prop bank view. So the prop bank view can reveal the semantic roles of the predicates, of the arguments of the predicates in this sentence. So it's like for each predicate or a verb, it has some related arguments. So these arguments can be some subject or object or some like modifiers that is related to these predicates. And these arguments are recorded in this prop bank. And this prop bank can show the positions of these arguments in the sentence. And it also uses different tags to indicate the roles of the arguments that is related to this predicate. So this is a sample prop bank view, and we can see that the argument 0 and argument 1 or argument or ARGM are tags. And according to the handbook, argument 0 is the object that gives out an action, and argument 1 is the patient, and argument 2 sometimes is also a patient, and argument 3, sometimes we have argument 3 and argument 4. There are some modifiers. There are some like arguments that describe the verb. And we also have this ARGM. It means some modifiers that is related to this verb. So in order to do the extraction, sometimes we can use this expert system. So expert system is a system that can do some decision making, like some human experts. So we can encode our human knowledge into many rules, in this expert system. And so when it is used to do the decision making, it just applies these rules to the current situation. So it uses a lot of if, then, else structures, and it wants to see which rule can be applied to the current situation. After we find this rule, we can do the following processing that is related to the rules to the current situation. So, the rule for us to find the time and location information in the sentence is that we want to find some tags in the prop bank. These tags marks the chunks that give us the time and location information. For example, we have a LOC log tag. That means that this chunk describes the location information, and we also have this DIR, meaning a chunk that describes the direction information. And these two kinds of chunks can be regarded as location information. And we also have this TMP tag that describes a chunk that has the time information, and we can use it as a time element. And now I want to introduce how can we find the subject, the predicate, and the object. Firstly, we want to eliminate the predicates in the unimportant chunks, because in the prop bank we have every predicate in the sentence, but sometimes these predicates are in some unimportant part, like the clauses of the sentence, or those adjective phrase or adverb phrase that are not important. These predicates cannot help us find the subject and the object in the sentence, because in each sentence there is only one set of subject and object. So we want to eliminate them, and then there might be several remaining predicates that are not in those unimportant chunks. So for the remaining ones, we use the first predicate with enough arguments to do the extraction, because sometimes predicate does not have any argument, so we cannot extract our subject and object. So in this situation, we move to this next remaining predicate to do the extraction. So in order to do the extraction, we just look at the arguments of this usable predicate in the probank and find the position of the subject and object. And we can use our probank to find the method and motivation information in the sentence. The method is also looking at the text, because I mentioned before that we have some modifiers arguments in the probank, and sometimes these modifiers are tagged by this MNR, which means a manner of a verb. So this manner is actually the method information that we want. And sometimes these modifiers are tagged by PRP, which means the purpose, and CAU, which means the cause of a verb. So this cause and purpose is the motivation information that we want. And now I will introduce a little about tracking the passive voice. Sometimes we have a passive voice in a sentence, and usually the object of a verb appears after this verb, but for passive voice, this object appears before the verb. So whenever there's a passive voice, we can see a string like this, which is long -1 after verb. And in this situation, we need to track back and find the first long phrase before the verb, because the object of the verb in the passive voice appears before the verb. So we find this long phrase, it is our object. So this is the result of our semantic parser, and we can see that for a very complicated sentence here, we can extract the 6 elements that we want very accurately. So after we get this data, this parse data, using our semantic parser, we can put, we can use it as our training data to train a sequence-to-sequence model, in which we input a single sentence and we can output these 6 elements. So it is actually a one-to-many sequence-to-sequence models. We can use our data to train it. So this is my presentation. Thank you.